So very good morning. I need to Dr. Power and So the topic today given to me is based on thermodynamics, and the topic I've chosen today is why high pressure cooker cooks food faster. So as you can see here in the first table of contents, I have really divided into five different parts. The first part being introduction, the second part being the thermodynamic concept, the third part being the schematics, and the fourth part being on how food cooks faster, and then the fifth part is the ending. So let's proceed to the next slide. So at first I will say the introduction of pressure cooking. So pressure cooking is an ancient cooking method that has recently gained popularity thanks to a new generation of cookers. These devices are electrical are much safer than those older models, which are equipped with mechanisms that prevent them from accumulating too much pressure. There is one important precaution to take when cooking under pressure, which involves adding water. Water and pressure cooking go together. In fact, water contributes to the high pressure environment that allows your food to cook faster. So that is actually the basic idea of pressure cooking. So next we go to thermodynamic concept. So example here is the concept of thermodynamic involved here is called an isohoric process, where isohoric process is better known as constant volume process. As an isohoric process is for one which that Vf equals to Vi, where delta U and delta V equals to 0. 0 in such process, the work done is 0, where dV equals to the pressure of dV is 0 and V is constant. Hence, from the first law of thermodynamics, dQ equals to du. Isohoric process, the total heat supplied or rejected is equal to the increase or decrease in the internal energy of the system. So as we proceed to the next slide is the schematics. So the first slide shows actually the graph of P against V to explain the isothermic process. Isohoric process, sorry. So as you can see in the first graph here, the graph says that the graph P against V is plotted, where an isohoric process, the area under the PV curve is 0, so no work is actually done. Whereas pressure is constantly increasing because pressure is constantly increasing with constant volume. And then at the side here you can see an example schematics diagram of a pressure cooker. Example, a simple pressure cooker diagram where water is added into the pressure cooker to a certain water level, and then the water is heated up through a heat source, and then the food is placed onto a cooker, which is then the when heat is applied, the temperature increases, so the water turns from liquid to vapor, therefore cooking the food with increasing pressure, and then excess pressure, then when the excess steam is released through a nozzle or regulator. So next slide. So overall, how does food cook faster using a pressure cooker? So what do water and pressure have to do with faster cooking? Cooking is raising the temperature of food until chemical reactions occur, such as those that break down tough tissue in meat or soften starch in vegetables. At higher temperatures, these reactions typically occur faster. The temperature inside the pressure cooker is much higher. Therefore, a liquid boils is determined by the pressure in the surrounding environment. Example, water boils in a regular pot at an atmospheric pressure at 100 degrees Celsius. And then the pressure inside the pressure cooker can be risen to additional 15 or 30 degrees Celsius. So therefore water boils at 121 degrees Celsius at that pressure. Because cooking reaction speed up at higher temperatures, your cooked food cooks faster and also does not dry out because the water remains liquid. So that's it for us. Thank you. That's it for me. Thank you.